Get started, 8:10, talking about paleoecology, dipping into the past, making our way back up to the present for a discussion of contemporary environmental problems next week and human ecology. A big focus today will be on human evolution, human ecology, in the deep time context. To get there, we'll look at some examples of paleoecological reconstruction from the Mesozoic to get a sense for how paleontologists can understand ancient organisms ecologically. We'll talk about the evolution of mammals and hominins specifically, and the ecology of ancient hominins. We'll talk about how hominins moved geographically out of Africa, spread around the world, and the correlation between hominin movements and extinctions of large vertebrates on various land masses around the world. Paleoecology. This is the slide I think we left off with last time in the context of the global carbon budget. And here we are in the Paleozoic when this dynamic was occurring, with the first time that large plants were growing to tremendous scales in the terrestrial environment, and in the process creating these vast deposits of fossil material, some of which ultimately contributed to our fossil fuel deposits as we know them today, particularly of coal. And we'll revisit that next week when we talk about the global carbon cycle again. But this is the Paleozoic, long before the evolution of dinosaurs. When we get into the Mesozoic and the so-called age of reptiles, if you want, the long-held interpretation for the mammals, the great lineage to which we belong, and the mammalian ancestors was that these mammalian ancestors were playing a very minor role in the Mesozoic when the dinosaurs lived. But research from the last 10 years has shown just how dynamic and complex the mammals were during the Mesozoic, during dinosaur times. So I'm going to give you a couple of examples of recent finds of mammals that illustrate their ecological diversity in particular. Here's an example of an ancient mammaliform found in the Middle Jurassic, so about 164 million years ago. Details that you're not required to remember for sure. What you're to get from this is just the way paleontologists interpret ancient organisms and their ecology. But here's one. This is what the paleontologist gets, this team, from a nice specimen, this slab from Mongolia. You get a slab and it's busted up, someone brings it in, or you find it yourself in the field during field work, and this is a really complete and very well-preserved fossil specimen, even if it looks like roadkill to you. What a paleontologist can do is get in there and start to isolate the elements that are visible, the different skeletal elements, and in this case, even reconstruct the fur that this organism had around it. That's what the interpretation of all this material here is that it's fur, and that actually left a trace. The first evidence for hair in the fossil record, a significant character to diagnose the clade to which we belong, the mammals. And so what these investigators did was reconstruct this creature based on a combination of anatomical evidence, given their knowledge of the way organisms live today, as something like this. It had a flat paddle-like tail. The vertebrae were all compressed, dorsoventrally compressed. There was an impression of that tail to some degree. The feet were seen to be wide, and the bones of the feet were very much like those on animals that have paddle-like swimming elements today in their limbs. The teeth indicated to them that it was probably consuming fish based on their morphology. The ecomorphology of those teeth indicated to these investigators that it was a swimming animal that was trapping fish by the teeth and probably powering its swimming with the tail and hind feet. And so they named it Castorocauda lutrasimilis, beaver tail otter-like thing, right? Yeah, not bad. And I've looked at it in some detail, and I think even though there's controversy and debate, I think it's a pretty fair interpretation given the evidence, given the anatomical evidence, because that's all you really had in that case. Here's another one, 150 million years ago, a little later in the Jurassic, this one from the western United States. And this is what the investigators had, this mass here of material. And you better like jigsaw puzzles if you're going to work in this field, because you have to recreate Humpty Dumpty from that. And it's very challenging. You need an exquisitely detailed anatomical knowledge and a big comparative understanding of other vertebrates in order to put these pieces back together. And that's what these guys did just, again, some years ago. It's a small creature, this fruitofosser. The feet had these big digging claws on the forefeet. And the teeth had these tubule, they're like tubes, dentin tubules. They don't have enamel on the teeth. They're just these dentin tubules. Very much like teeth you see today in aardvarks, somewhat like armadillos, creatures that eat social insects and invertebrates, including termites, especially with those forefeet, those good digging forefeet, because the animals that get into termitaries, which tend to be very hard, need to break into them. They need power in the forelimb elements, power up here, and then heavy claws here. And so they reconstructed little fruitofosser as this scratch-digging, termite-eating creature from the Mesozoic. And again, I think it's a pretty fair interpretation given our knowledge of contemporary mammals for this quite ancient mammalian relative living with the dinosaurs. So all of a sudden, just in these 10 years, you're getting a lot more diversity than existed than was interpretable from the record previously. You have something swimming in the water, maybe catching fish. You have something on land digging and eating insects. That kind of ecological diversity wasn't known for this period until recently. Another guy, this one from the Cretaceous, again out of China, Repenomamus. It's one of my favorites. It's a favorite for a lot of mammologically inclined people who are overwhelmed scientifically in many contexts by the enthusiasm for dinosaurs. Well, the little mammals are getting their day in the sun now, especially with fossils like this, little Repenomamus, because Repenomamus was so well preserved that you could look in its belly and see what it ate because the stomach contents were preserved. So you reconstruct Repenomamus itself, and then you can reconstruct the creature that's inside of its belly based on the bones that are present in its belly. And what do you know? What did it eat? Well, it had a little baby dinosaur in its belly. So that was nice to turn the tables and have a little mammalian ancestor chowing on a little baby dinosaur. Cool. I had to invent a new word for that. Dinosaurovore. Why not? Repenomamus was a little dinosaurovore. Pictured here, something like I don't know. What does it look like to you? A long bear? A long small bear? Sure. Eating a little Psittacosaurus, a little baby dinosaur, while something like Archaeopteryx looks on. Apparently appalled by the scene, judging from the look on its face. So you can see the kind of diversity that you're getting in the Mesozoic for these mammalian relatives. The vertebrates, generally speaking. Remember that our mammals are just a twig on this vertebrate phylogeny. You have your fishes, you have your amphibians and reptiles, including the birds, and you have your mammals. One of the major characters to diagnose your mammalian clade is having hair. You've never seen an animal outside of mammals that has hair. If you have, I'd love to hear about it. It's a unique character for the mammals, hair of the type that we have, that mammals have, that all mammals have. So that's just to position ourselves on the phylogeny. This you certainly don't need to know the details of, but it's to show the diversity within the living mammals. These are all lines of living mammals. You know, elephants here, armadillos on this branch here, members of the group that includes the sloths. You have the bats way down here, and your antelopes and ungulates, all mixed in with them, the carnivorans, shrews and moles. And then this clade here that includes rodents, lagomorphs, primates, tree shrews, flying lemurs. And there we are, somewhere in here, in the primates. Now, the primates may be closer to the flying lemurs than they are to the tree shrews. There's always debate about the topology of the tree. But what's clear is we're members of a branch within this phylogeny, member of the primate group. We're specifically members of the family Hominidae. And this is another place where the science changes, the taxonomy changes. And you go to another class in this department, they might define Hominidae differently than I'm defining it here. But this is the most common contemporary use of Hominidae, the way I'm using it here. But there are differences. Who's that? Orangutan, right? A great ape. From Asia, in that case. Who's that? Gorilla. Africa, of course. And that? Chimp. And that? Bonobo. Yes, not a chimp, but very closely related to the chimps. And these guys are more closely related to these guys than they are to these guys. So this is a branch outside of the group that includes these three. And then, of course, we also have ourselves. Yeah, represented by my girl there when she was younger. Ready for football season, it looks like. So this clade that includes, well, so these are all great apes. These are all great apes, but here's one branch outside of the clade that includes these four. And the group that includes these guys and their closest relatives can be distinguished from these guys. A little phylogeny would probably help here. Let's do that on the board real quick, just to get your bearings. So we have ourselves, and we'll just talk about the living forms here on this phylogeny for the moment. And then we have a chimp, right? Who's this branch with chimp? Who's on the branch with the chimp here? Yeah, bonobo. And then orang out here. And what we're doing is calling the entirety here Hominidae. So these whole groups, the whole group includes the Hominidae. But you can have separate names for this line, this line, this line, and this line. And that's what we do. And that's where the terms, well, first you have the Hominidae. And that's the typical suffix for a family in mammals, the ide. And that's where we get the hominid from in English, the colloquial, a shorthand for that. And then we can speak of a homininae, the classic suffix for a subfamily in mammals, and the hominini. Oh yeah, it gets real tedious. Hominini, the tribe to which humans and their closest relatives belong. Tribe being a taxonomic level, a rank, taxonomic rank. It's just semantics, really. It's driven by our understanding of the phylogeny, and that's what's important. So what I'm calling a hominid is any member of this clade. What I'm calling a hominin is a member of this clade that includes the relevant ancestors, to the exclusion of chimp and bonobo and gorilla. And these guys would be gorillini, gorillinini, paninini. You know, so you have these other tribal names for those groups. Hominin. So our shorthand hominin is the one I'm using to refer to humans and humans' closest relatives. For example, the Australopithecines that we'll take a look at. Anyone want to ask a question on that? You really don't need to worry. As long as you're using hominid and hominin fairly, you can read a little piece on it here by clicking that button if you want some further clarification. The Australopithecines are some of these very close ancient relatives of humans that we include in the hominins. Okay? And they've been known about for a long time. Raymond Dart found the first ones in the 1920s. It was some time before they were agreed upon as being closer to us than they are to the apes. But that agreement came soundly by the 1950s. And the first one was a young one, a baby Australopithecine. And many, many have been found since. It's a pretty darn good record, this record of hominid evolution, and relative to other major groups. One of the problems, though, is that the sites that have produced all these fossils are themselves relatively restricted geographically. They primarily run down the great rifts of Africa, from Ethiopia in the north to South Africa in the south, in an arc like this, in a line like this. In these highlands, this is a relatively high region. You know, it's about a mile high for the most part, this whole area. There's valleys, there's tremendous mountains, there's incredible diversity of landscape. But there are no specimens of ancient hominins from the whole of Central Africa or West Africa. If you look at the eco-regions of Africa, what you're seeing is that you're not getting any fossils from the forest zone. They're all coming from this elevated zone where you have the rifting, the erosion, the conditions that produce great fossils. Were hominins living elsewhere in Africa? Almost certainly. Were they living in these parts of Africa? Almost certainly. What types of habitat they were living in is a really interesting and important question in paleoanthropology. Were they living on the coastlines? There are no sites from ancient times from the coastlines. Sea levels have gone up and down and up and down, and either erased many of these sites, or many of the sites are out there underwater. We don't know enough about the coastlines for these early, very ancient times. Recently, the earliest fossil hominin was discovered from, and it represents the westernmost site out here in Chad. So some 6 to 7 million years ago, very near the time that the ape lineage, the chimp lineage, and chimp and bonobo lineage, and the human lineage are thought to have separated around 7 million years ago. Based on the genetics, based on molecular clock evidence, that's usually about the time you've heard over the last decade. 7 million years ago for a split between chimps and relatives and humans and their relatives. So here you are approaching that date with your fossil evidence, way out here in Chad. And this is unforgiving country. This is extremely difficult work, not to mention the political and human-related problems you get into out here, the militaristic and tribal problems you can get into when you're working in extremely remote areas like this. It's just the physical climate. It's dreadful. Sandstorms and the heat and the cold at night. Tough working conditions. But what these teams of French investigators found over many years of work were some important specimens to represent the most ancient known hominin from that area. Now, in the past, that area was not a desert. The French team, in their reconstructions, have used the Okavango Delta down in Botswana today as a model for what that system would have been like then. It was this vast, swampy, well-watered area with lots of trees and some open country mixed together. So a patchwork of different habitats distal to the aquatic habitats. The aquatic habitats predominated. It's full of otters and hippos and other aquatic forms, not to mention the turtles and fishes and things. And then some dryland, upland forms, lots of those too, and some forest forms. And the forest element is consistent generally for these very ancient times. That alone was a significant aspect of these discoveries. The link between these ancient hominins, which are interpreted as walking on two legs. They're bipedal. That skull that they found of Sahelanthropus, the position of the foramen magnum in particular, the way it's set, the foramen magnum, which is the hole in the back of your cranium where your nervous system exits and enters, the position of it is interpreted as indicating that the animal was upright, that it was erect, that the head was held upright during bipedal locomotion. So the environment that occurred in is an old question since Darwin, and a really important question. So when these guys were finding evidence for trees in this generally swampy landscape, that has bearing on when did bipedalism originate, if indeed these things were bipedal, as they're interpreted to be. So see how they get layers of controversy in here? You first have to establish that it's bipedal, which they've done to many people's satisfaction, and then you have to work on the environment. Well, where did that arise? Okay, get your environment. Say it's this. Well, then how did the bipedalism arise? Why did it arise? What were the forces that influenced it? What were the costs and benefits? And that's this whole field of study. It's a fantastic field of study in paleoanthropology, paleoecology of hominins. Great field of study, and you can do a lot with it here at Berkeley. Berkeley's been a leader in this research for 50, 60 years, at least longer. Berkeley has played a tremendous role in global physical anthropology research, and it continues to do so today, particularly through field studies in Ethiopia. Ethiopia is not a desert in the same way that Chad is a desert, but it's these dry badlands that have these eroding hillsides. You know, the goats will walk across, the people will walk across, but there's relatively fewer people there than there are in many of these other areas of Africa. So it's this open country, and these hillsides erode out really well. The rains come at a certain time of the year, rinse the hillsides, expose new fossils every year with each rain. So you can go back year after year and continue to look for new stuff. Remember that paleontologists don't go to a place, and here's an old Berkeley paleontologist who continued to go year after year for so much of his life. That's Desmond Clark. He's passed away. But they don't go and they don't go to a place and start digging, of course, right? You go walking. You go walking and you look for things on the surface. And if you find something intriguing, that will lead you to cover a wider area. And if you find something really important that might still be in there, if you can interpret where it's flowing from, then you start digging. Then you would engage in your dig. But the early stages are usually walking the landscape. And how fun is that? Walking the landscape, looking for important things. Really can be exciting work, but unforgiving work too. Extremely difficult circumstances and in very remote places, and doesn't pay squash, and it will not make you famous. So be careful if you get too excited about this stuff. So what Berkeley teams did in Ethiopia was discover really relatively complete remains of ancient hominins compared to Sahelanthropus or many later ones. You had a partial skeleton. You had great craniodental elements of this taxon, Ardipithecus, which was actually found before Sahelanthropus, somewhat later. There are specimens from 5.6 million. There are specimens from 4.4 million. So you can, if you have them from 5.6 and you have them from 4.4 in this genus, sure, connect the dots. Maybe that was its tenure in Africa, this genus. Now, the skull looks a lot like the skull of Sahelanthropus in the general morphology and in many of the details. So it's possible that you really should just be talking about one genus across that whole time period in that space, and Ardipithecus would have priority taxonomically. So you may just be fine talking about Ardipithecus for that whole period, 7 to 4.4 for the north of Africa at least. One of the defining traits of this that links it to the later hominins is the size of the canines. The canines are relatively small compared to those of chimps and gorillas. Bonobos have relatively small canines. Here's Ardipithecus here, and here are later hominins, and here are modern humans. The canine reduction is occurring in the evolution of this lineage, as many other changes are occurring. In the brain, changes are gradually occurring during this period, and they'll change much more rapidly as you get into later phases of evolution, expanding of the brain and the complexification of certain areas of the brain. Of course, the walking on two legs. The role of the hands in the life history of these animals is so important. We're handy and we're brainy. Humans are, and you see a lot of interesting trends in the structure of the hands and the structure of the brain in evolution. But these hands are not entirely like our hands. These are long fingers. The phalanges, in many cases, are curved. The arms are long. The legs are relatively short, but long compared to a chimp. So you get this mosaic of features. I mean, that creature reconstructed like this, maybe. Discovery Channel did. This female, these feet, a grasping big toe. So these big feet that you could grasp with your big toe. Nice trick. And what does that help with? Well, that helps in clambering around branches, right? So a creature built like this probably could have climbed quite well. Indeed, you put a bonobo, you stand up a bonobo, and this is based on a photograph, and there's a link to a paper if you want to click it. I mean, the hands of a bonobo, and the bonobo has relatively long legs compared to a chimp. These things are not, broadly speaking, that dissimilar. Stand up your reconstruction of Ardipithecus, stand up a couple bonobos, and you're really getting close to some really interesting aspects of the shared history here. Yes? Well, is there any short explanation for why hominin arms become relatively shorter in evolution? Well, long arms like this tend to be associated with suspension and moving in trees. So one explanation could be a progressive movement away from trees toward a more dedicated bipedality in a strictly terrestrial context. So that alone could account for a shortening of the forelimbs relative to the hind limbs. Yeah. Now, Ardipithecus was found as fossils very consistently with forest-living taxa, forest-living organisms associated with it. One of these other great ways we have access to its ecology. Well, who did it live with? Who did it live with, and what were they doing ecologically? Well, it was living with forest antelopes. It was living with monkeys that preferred trees. But in the same deposits from that area, you had animals that lived in open countries, and you had some animals that lived in